Hello and welcome back to our discussion of air masses, mid-latitude cyclones, and weather. In this segment, we'll be talking about weather station data, symbols used to document these conditions, reading wind direction and speed, and then writing and reading pressures. In your lab book, you'll have and your textbook possibly too, you'll have a group of tables that provide you with a lot of information that can seem a little bit overwhelming. On the left-hand side here, I say see figure 15.5 for a complete list. That's going to be from a slightly different lab book, so you can go ahead and ignore that if you're not using a published lab book for this class. But I have bullet point lists here for the types of data that we will generally see. Cloud type, which we won't focus on too much right now. Temperature, dew point, everything in bold here is really relevant. Current weather, wind speed and direction. Weather in the last 4 hours. So often we'll have different time spans involved in the weather station reading. And then pressure and pressure change. Pressure change is fairly important because it allows us to predict what's going to happen. Transition from a high pressure to a low pressure tends to suggest there's a kind of front moving in, or a weather situation is going to be changing relatively soon. The symbols we have in the center part of this particular slide here, these are clouds up at the top. We're going to kind of ignore clouds for right now, but you're familiar with stratus, cumulus, and stratocumulus, and you can see that stratus is basically a horizontal line. Cumulus is a kind of puffy shape, and then stratocumulus is a line with a kind of puffy shape below it. And then as we move, that's for low-level clouds, right, close to the Earth surface, within that less than 2,000 meters. And then as we go, vertically up to mid and high-level clouds, we get a combination of different kinds of clouds that we've seen: altocumulus, altostratus, and so on. What we do want to pay attention to down here on the bottom of this central block of tables is cloud cover as a percentage of the sky that is exposed. 0 would be a kind of open circle. And then as we move to 10, 20, up to 90 and 100% down at the bottom, we begin to fill in a circle. I'll show you what that circle is later on. Types of weather. We'll include fog, rain, drizzle, and snow. We'll not worry too much about all of these. We have different kinds of features: dust devils and funnel clouds in the block of text and symbols on the right-hand side. Hail and freezing drizzle, very specific, or freezing rain. What we're interested in maybe, though, is basically rain, drizzle, and snow. And I've seen these symbols drawn in different ways in different diagrams, but this gives you the general gist of it. And then at the bottom here, we see wind velocity going from low velocity at the top to high velocity at the bottom, and it's given here as increments of 5, 10, 25. And so what you see here is that the short line attached, I'm going to go with this little stick here at 5, the short line attached to my longer wind direction indicator is worth 5 miles per hour. The longer line is a value of 10. As we continue from low values to high values, we continue to add sticks, add little lines. So here we've got 10, 10, and 5. That gives me 25. Then we jump here to a flag. The flag has a value of 50. So down here on the next level down, we'd have 50, 60, 70, 75, and that's what that level is, all the way up to sort of 145. But obviously, we can have faster winds. Hurricane velocity winds are much faster. Okay. All of this gets combined at a particular geographic location called the weather station, where we can read all of this information. We can plot this up on a map. What you end up seeing in the news is you see the outcome of whatever data have been collected at different stations across whatever continent you're looking at or interested in, and they're plotted up. But before you get to the weatherman's map or the weather person's map, you've got to plot up the data and make your own map. So the first step is to collect that data. Where is it coming from? It's coming from weather bugs, and it's coming from weather stations at different colleges. It's coming from NOAA sites. And then the next step is to plot it up and to begin to make the map. So on the very right-hand side, we have the parts of this diagram. So here's the circle. That circle corresponds to cloud cover. Here is the long line that corresponds to the wind direction. In this case, we're always going to read from the end of the line to the circle. Wind is blowing parallel to this little circle with a fletching and arrow on it. And so it's, in this case, it's from the northwest. Okay? I'll erase this to clean this up in a second here. Okay? So the wind is out of the northwest, and it's blowing at, in this case, if I'm reading this, about 15 miles per hour. Visibility code, we're not going to worry about that. Cloud cover, we can see low cloud type here. So we have horizontal lines. So we have stratus in the low atmosphere. In the mid atmosphere, we have something like altostratus. And then in the upper atmosphere, we've got cirrostratus. So we've got a lot of layered clouds in this particular example, going from low at the bottom, low cloud, to high cloud level at the top. We have pressure measured in this particular example in hectopascals, or what's usually going to be called millibars. Okay, so it's 987 millibars. The answer is no, it's not actually 987 millibars. Okay, why is this? Well, it turns out that when we write pressure, they tend to abbreviate. So this is really 998.7 millibars, and that means that we cut off either the 9, or in some cases you could have something like, I'll write this at the bottom, 1012. You might have 1012 4, so you would be written as 1 2 4, and you would write that out as 10.4. Okay, so we cut off either the 10 or the 9 from the reading. And so that means if we come down to the bottom here, or just below that 998.7 millibar reading, this is actually not 18 millibars of pressure change in the last 3 hours. It's 1.8 millibars of pressure change. And then finally on the right-hand side here, we have a little symbol. It looks like a check mark. It shows down, so we see slight down and then an uptick. Sometimes there's a positive or a negative here to tell us what's going on with pressure, but in general, that means pressure has been going up within the last 3 hours. It's risen 1.8 millibars in the last 3 hours. So if we want to know what the pressure was 3 hours ago, it's going to be, in this case, 998.7 minus 1, sorry, let me just fix that, okay, minus 1.8, okay, 7196996.9, that was the pressure 3 hours ago, and it's gone up 1.8 millibars. A couple other things we want to note. Sometimes we put past weather down here on the right-hand side in the box, so that would be symbols for past weather, kind of similar to symbols for present weather. Present weather goes here next to cloud cover, and then up here, this number, which is in degrees Celsius, and this one is also in degrees Celsius. We've got temperature, which is -10 in this case, and dew point temperature, which is just lower than -10. It's at -12. So we're not quite at the dew point temperature in this particular example. Okay. If we jump over to a blank example here, we can write out the current weather. We can write out wind direction, cloud cover, the barometric pressure, and so on. I didn't put change or anything like that on here, but that won't make too much of a difference for us as we go on to plot our weather map data. So we can start with cloud cover. Okay, that's right here. I give us 6/10 of a 6/10. So that means it's going to look something like this. And this is my shading going on here. I'm going to shade that guy in. I'm going to shade in my cloud cover. I have a wind direction from the northeast, so that means the line is going to point towards the northeast. I have a velocity of 15 miles per hour, so that means I need a long line and I need a short line, the little fletching lines drawn on that symbol. Okay, temperature, atmospheric temperature is 15. That goes there. Dew point temperature, what do I have here? I've got 14. That goes right down there. Barometric pressure is 008. In this case, I'm just going to write it out, 1008. You don't have to abbreviate for this particular class. And then the current weather is snow, so I've got my little snow symbols on here. Let's see, so I have everything accounted for: temperature, dew point, barometric pressure, wind speed and direction, cloud cover, and weather. Most of that is stuff that you're going to end up plotting on your diagram when we go to talk about weather fronts and evaluate weather fronts. So that's really all you need to get started. We can do another one really quickly. Temperature in this case is 25 degrees. That goes there. Dew points at 25. The weather situation is rain. Okay, so we're having some precipitation going on here, and that makes sense because we were at the dew point. And so rain will be something like this. Okay, 3 little symbols there. Cloud cover is at 2. So let's see where we're at with 2. So smaller percentage of cloud cover looks something like this. Okay. Now we might expect, if we had lots of rain, to have full cloud cover, but just for demonstration examples, you can kind of just follow along with me. Our barometric pressure is 989. Remember, I'm not cutting anything off of this. It's in millibars. Wind speed is 50 miles an hour, and it's coming out of the southeast, so I'm going to extend my stick to the southeast. And now I need 50, and that's going to be one of these flags. Okay, so that's a pretty fast wind with rain, cloud cover, and temperature and dew point temperature identical. Okay, so that's how we go about plotting up some of our weather data. Okay.